Hello, everyone. The main goal of this presentation today is to make you think of infectious disease in terms of statistics, in terms of odds, and not so much in terms of symptoms and types of bacteria and medication and all that. Of course, we will need to think about the types of microorganisms that will influence a type of infectious disease. But the main goal today is to give you an overview of what an infectious disease is. So the first thing you need to do is to keep in mind the definition of what an infectious disease is and versus what an infection is, right? So this is something that you need to do on your own, and I want you to want to make sure that you have these terms in mind and they are understood right off the bat. So when you're thinking of an infectious disease, I want you to think of the odds of getting sick by something that is called an infectious agent, right? So let's say that we do have like on, so that I'm going to draw an equation, and do not panic, it's not very complicated. It actually is very easy to understand. And what I want you to think about is this, right? So an infectious disease is caused by something that we called an agent. And that agent can be bacterial, it can be viral, it can be a parasite, it can be many different things. So an infectious disease, or the odds of getting sick from an agent or getting an infectious disease, can be measured in terms of different factors. So let's look at that. So the first thing that we will take into consideration is the agent. And understand that agents are not all created equal. So some agents are highly aggressive because they have tools that help them penetrate the skin, the muscle tissue. They can spread very quickly. They can attack red blood cells or immune cells and all sorts of things. So we would say that these microorganisms are highly aggressive towards us. It doesn't mean it's aggressive towards a lizard, but it can be very aggressive towards human beings, for example, or other animals. And the aggressiveness of microorganisms, we don't say they're aggressive. We can say this, but there is a specific term for that. And that specific term for that is called virulence. So it can be highly virulent, it can be low virulence. So you need to think in terms of, well, virulence is something that can be measured depending on different factors. And this virulence can be it can be high or it can also be low, right? So if you think of, say E. coli, well, E. coli can be, different strains can be very, low virulence, and the strains we work in the lab with, for example. But some other strains of E. coli can actually kill you if you're exposed to it, right? So virulence is some kind of a switch. It can be high, low, it can be in between. Now, virulence is also the effect of virulence on an infectious disease is also compounded by something else. And that something else is known as the number of say, cells, if we are talking about bacterial cells, but it can also be, say, the number of particles if we're talking, say, about viruses, right? The number of cells and particles will influence the degree, the odds of getting an infectious agent. And it's compounded by this virulence. So for example, let's say that I have, in order to get an infectious disease, so let's say ID here for infectious disease. And let's say that I have a highly virulence, so that's my virulence factor here. And that's why I have a V here, and that's an arrow here. So let's say that I have a highly virulent microorganism. And if it's really high, then the number of this microorganism in order to get an infectious disease doesn't need to be very high. So I could be a low number. I could have a low number of particles, low number. But if I do have a highly virulent, then yeah, it is likely that I'm going to develop an infectious disease, right? If we look at this in reverse, if I have an agent that is low virulence and I have a low number, well, guess what? Not very likely. In order to develop an infectious disease with a low virulence factor, I need to have a high number. Hopefully this makes sense to you. Now, this is very, very simple, right? That's a simple equation, but we are all different, and all of us are more or less resistant to certain types of infectious diseases. So there is something called immunity. So if your immune system is really reactive, and hopefully it's not too reactive, but it's like reactive, it protects you well, then it's going to protect you against infectious diseases. So you have a healthy immunity, infectious disease are going to be, the odds are going to be kind of low, right? So say that I have a high immunity, I here. The chances that I'm going to develop an infectious disease are kind of low. In reverse, say that we have someone that has a low level of immunity. So how do you get a low level of immunity? Well, there's different ways you can get that. AIDS is one of them, but there's also other types of diseases. And some people that have, say, an organ graft, or a liver graft, or lung, or heart, and all of that, they need to take medication for the rest of their lives to tame the immune system, because otherwise it could be rejected. So if you have a low immunity, the chances of getting an infectious disease is much higher. Now let's look at what happens when we consider the immunity factor here, when we consider this here with the virulence and also the number of particles and cells, right? So say that I have a low immunity, right? So I have a low immunity here. It's not going to protect me very well. And because I have a low number here at the denominator, in order to have a high odds of infectious disease, this virulence factor here doesn't need to be very high. In other terms, if you have a low immunity, you're not protected very well, it is very likely that even bacteria that have a low virulent capacity, they're not very aggressive, in other terms. If you have a low immunity, it is likely that even lowly virulent bacteria can make you sick. It's not even so much a question of number here, right? You have a very low immunity. It's not going to protect you very well. And bacteria, even if they are lowly virulent, the virulent factor is low, then it is possible, the odds are that you could develop an infectious disease. Of course, if you have a low immunity and the virulence is very high, then of course you're going to, that's very bad news, right? But just imagine that you have common bacteria in your environment, and these bacteria are not virulent, they're not aggressive. And the number of these bacteria, number of cells present at any given time, if it's very high for someone that has a low immunity level, well, you know what? The chances of developing an infectious disease in such a case is much higher. This is why AIDS patients that have full-blown AIDS will usually be affected and even die from the effects of bacteria that are very low aggressivity, very low virulence. And these patients will be affected, will need treatment, and even might die from very common non-dangerous bacteria for the rest of the people that have a normal or high immunity. So you see, my role today was really to give you, hopefully, a good understanding of what an infectious disease is in terms of the odds, in terms of, well, what are the chances I can get sick? So you will read for the rest of your life, right? You will read news. You will look at articles in newspapers. You will see things on the internet, newspapers, websites, blogs, and all of that. And they will tell you things about infectious diseases, the way they're spread, how dangerous they are, and everything. Well, what I want you to do is always think in terms of three things. Virulence, for one thing. What is the number? And what is the immunity status? If it is a population that's at risk because their immunity is low, because their nutrition is not what it should be, because they're stressed out, because the population of individuals, say in a camp, is very high, etc., this is going to have an effect on infectious disease, the way people are affected, but also, and very importantly, the way it spreads.